Greetings, mathematicians. We have the warm-up for day one. Solve and graph the following inequality. Here's the inequality. 2 is less than 4x over 2 minus 6, less than or equal to 12. So what we need to do, again, is isolate that variable x, and we're going to do that using a variety of steps, making sure to do the left, the center, and the right. So the first step that I'm going to do is we need to undo this minus 6. So we're going to go ahead and add 6 to the left, the center, and the right. Make sure that you write your equivalent inequalities as you go. Okay, 2 plus 6 is 8, less than 4x over 2, less than or equal to 18. Okay, so the thing that I see is we have this 4x over 2. This can be simplified. That's actually really nice. So what is 4 divided by 2? That's just 2, right? So this is equivalent to 2x. Okay, and then I'm just going to go ahead and pencil in everything else. Okay, and then last step, I need to divide everything by 2. 8 divided by 2 gets me 4, less than x, less than or equal to 9. Okay, this is a totally valid answer. It goes from least to greatest, less than, that looks good. Let's go ahead and use this number line. So I'm going to put 4 down here, 9 up here, right? And this is technically an AND statement. So we have x is stuck between 4 and 9. So we have a open circle at 4, a closed circle at 9, and then we're shading in between because it has to be between 4 and 9. And that is our answer. Learning target number 17, we are talking about absolute value inequalities. Our essential question, how are absolute value equations and inequalities solved and graphed? So absolute value, okay, it is written as the absolute value of x. It is the distance the number is from 0 on a number line. Okay, the absolute value of a number is always non-negative. Okay, so we have 3 different examples down here. Here's the first one, here's the second one, and here's the third one. So let's see what's going on there, right? So this just says the absolute value of 7 is equal to 7, right? That's a pretty easy example, right? So if we're thinking about it on a number line, we're thinking about how far is 7 away from 0 on a number line. That's all that absolute value means, right? So what is this distance? Well, that distance is just 7 units away, right? So the absolute value of 7 is equal to 7, okay? Let's look at this one right here. The absolute value of negative 7 is equal to 7. So same thing, we're trying to figure out how far is negative 7 from 0 on the number line, right? So what is this distance? Well, again, it's only 7 units away, right? So that's why we have a positive answer there, okay? This last one is a little bit trickier, right? But basically, we have the negative absolute value of negative 12 is equal to negative 12, right? Well, okay, so treat absolute value just like you would a grouping symbol, right? So what is the absolute value of negative 12? Well, that's just 12, right? So we just go ahead and write that 12 down. But we have this negative sign out front. So we have negative 12 is equal to negative 12, right? So because that negative sign is on the outside, that's why we have that negative answer there. Okay? And then here we have some absolute value equations. We have 3 different cases, right? So for this first one, this is red. The absolute value of x equals 8, okay? If you see, we actually have 2 answers, right? Our first answer is positive 8, x equals positive 8, and our second answer is x equals negative 8, right? Because both positive 8 and negative 8 are 8 units away from 0, okay? The second case, we have the absolute value of x is equal to 0. We only have one answer there, right? The answer is x equals 0. We only have one answer because there's only one number that is 0 units away from 0, and that number is 0. Okay? And the last case that we have is the absolute value of x is equal to negative 10. Distance is always a positive value. It's never negative. This is saying that the distance from a number to 0 is negative 10 units. That does not make sense. Therefore, our solution is no solution.